All right, we talked about proportional relationships. We said had a constant. Same thing today. We're still doing that. You have a little triangle on your notes. Do you remember yesterday we said k equals y divided by x? So there's a little triangle here that you can use to help you remember that. If you split it, like cut the top off like this, and put y inside there. Now this big bottom part you're going to cut in half. K and x. And this is the way it goes. If you're looking for k, you're going to cover up k. And what's left is y, you can see it, y divided by x. Y is on top, right? If you're looking for y, you cover up y. And you're left with k times x. So that's what we're looking at. It's all the same. K equals y divided by x and y equals k times x. It's the same. Let me erase some of this extra stuff I put. I'll just redraw this. So y goes on top, k on the left, x on the right. So every time you get a graph, I want you to, just like we label the x and y on a table, label the x and y on a graph. So the y is the vertical one, x is the horizontal one. And we're going to make a table. So find the points that are easy. Right here, right, we have 0, 0. And we have 5 and 3. Which one's the x and which one's the y? Right? X is 3, y is 5. And if you look out here, I think I see 6 and 10. So which one's the x? 6, and then y is the 10. So here's what we have. We have the 0, 0, right? That's called the origin. It's got to have 0, 0. We also, oops, I turned my thing off, sorry. We also have a constant. And what the constant does is it makes it have a straight line. So these are the two things that make it proportional. It goes through the origin, it has a straight line. On your table, to prove it had a constant, you divided, right? Because k equals y divided by x. So as long as the constant was the same all the way down on your table, you were good. So that's what we're going to check next. We don't have to do 0, 0. You know that doesn't work. So let's divide the x and y. So y divided by x, I'm going to do 5 divided by 3. I can leave it like that, or I can make it 1 2/3. Ooh, I don't know what that was. The next x and y is 10 over 6. If I simplify that, that simplifies to 5/3, doesn't it? So do I have a constant? Yeah. K is 5/3, or 1 2/3. The funny thing is, improper fractions are okay for the constant sometimes. So is it proportional? Does it go through 0 0? Yep. Is it a straight line? Yes. Let's look at the next one. First of all, label your X and Y. Oops. I keep erasing my stuff. I know I wrote it differently this time. That's okay. Don't fix yours. It's just important that the notes are here. So let's put some numbers on our table. Find an easy place to read the X and Y. I think here's one. Here's one, and I'm lazy. I do the easy. Hit pause. If you are having trouble with this, reading the graph, we need to work on that, because we've got to make sure you can read the graph. So the rate of change is the constant. That's y divided by x. So pick any y and divide it by x. It doesn't even matter which one you pick, because the truth is 4/10 turns into 2/5, right? They're the same. You could also say 0.4. I don't even care. 2/5 is perfectly fine. And so is it proportional? Does it go through 0 0? Yes. Is it a straight line? Yes. If I divide everything on the table, do I get the same answer? It has a constant. It doesn't change, right? So yes, it is proportional. Don't assume the answers will always be yes. They might not be. How about this? Do we go through the origin, and do we have a straight line? Yes. No. What's wrong with this one? It doesn't go through the origin, right? What's wrong with this one? It's not a straight line. So here's what I want you to do. I want you to tell me, what is the constant for this graph? Four over 12. Can you simplify that? Of course you can. I wouldn't ask you if you couldn't. Constant is 1/3. Ta-da! Is it blowing your mind? You doing okay? All right, label your X and Y. So it says create a table and use it to determine the constant rate of change. This is how I like to do it. I think this is a perfect question. So X always comes first. Find some easy to read X and Y. Of course there's 0 0. Boring, but useful. Actually, it's not even useful. It's just easy to get. What about this one? Which one is Y? Is it 5 or 100? 100. X is 5. See, what else is easy to read? Maybe here? Is that 35 and 800? Or is that 40 and 800? I don't think my numbers are working. Those don't come out the same. Let me see. 0, 0, I'm going to keep. I am just not sure what else. Maybe here. 20 and 450. You know what, guys? I just can't read any of this. And if I can't see it on mine, how hard is it on yours? I'm going to cross this out. Maybe you're smarter than me and you can do it. I know you're smarter than me, but I don't know about that problem. All right, flip your paper over. We got one more to do together. Jason is building a model of his police cruiser using a scale where 3 inches is equal to 10 feet on the actual car. Which graph best represents this relationship? Okay, here's the deal. Whatever number comes first is y. Okay? Because it has to be y divided by x. So it has to be 3 and 10. So the first thing I would look for is the graph that has a y that's 3 and an x that's 10. And that looks a little bit hard to find, actually. Maybe that. This is 3. Is that a 10? What's this down here? Oh, I don't even know what that is, but I know it doesn't go through the origin, right? It has to go through here, so I know it's not C. Thank goodness, because I can hardly keep it on my paper. I would say that's 3 and 10. So if I've got 3 inches is 10 feet, then 6 inches is 20 feet. Let's see if that works. I think it does. If you're really, really worried, you could say, well, then 12 inches is 40 feet. But I'm thinking we got it figured out. Sorry about that last one, guys. I'm not sure what's going on with that. I just could not see any points that made sense. If you're having trouble with the graph, we need to practice just the graph. Once you get the graphs, those have to be easy for you to read. It's worth the practice.